Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem number 12, integer to Roman. This is a medium difficulty problem, and it's a fantastic example of how to approach problems using dynamic programming concepts. The challenge is straightforward. Given an integer, you need to convert it into its Roman numeral representation. For instance, if you input 3, the output should be III. If you input 1994, the output will be MCM_XCV. Seems simple enough, right? But there are some nuances to consider, particularly when dealing with larger numbers and the specific rules governing Roman numerals. We'll explore those rules and see how we can efficiently solve this problem. The input will always be a positive integer, and you can assume that the input number will be within the valid range for Roman numeral representation. Let's dive into some examples to solidify our understanding. Understanding with examples. Let's look at a few examples. If we have the number 1, the Roman numeral is I. For 5, it's V. For 10, it's X. Simple enough so far. Now let's consider 4. It's IV, not III. This is crucial. We see subtractive notation here, where I before V means 5 minus 1 equals 4. Similarly, 9 is represented as IX, 10 minus 1. 40 is XL, 50 minus 10, and 90 is XC, 100 minus 90. This subtractive notation is key to understanding the patterns and designing an efficient algorithm. Notice that we only subtract smaller values from larger ones, and only when it creates a more efficient representation. Let's consider a larger number, 1994. This becomes MCM_XCV, representing 1000 plus 900 plus 90 plus 4. Understanding these patterns and the subtractive notation is the first step towards an effective solution. We'll now explore how we can translate this intuition into code. Brute force approach. One naive approach would be a brute force method. We could create a massive if-else chain, checking for every possible number and returning its corresponding Roman numeral representation. However, this approach is incredibly inefficient and impractical for larger numbers. Imagine how many if-else statements you would need. It would be extremely long, difficult to maintain, and would have a terrible time complexity. Essentially, for every input number, you'd need to check against all possibilities before outputting the result. Its time complexity would be fairly awful, essentially linear at best. It could be much worse, depending on how the code is constructed. This highlights the need for a more sophisticated and scalable solution. Let's look at a more efficient strategy. Optimal solution. The optimal approach involves leveraging the patterns we observed in the examples. We can create a mapping between integers and their Roman numeral representations. This mapping will include both the standard values IV, XL, CD, M and the subtractive combinations IV, IX, XL, XC, CD, and CM. Then, we can iteratively process the input number, checking if we can use the largest possible Roman numeral value that is less than or equal to the remaining number. We'll subtract that value and append the corresponding Roman character to our result string. We continue this process until we've processed the entire input number. This approach is much more efficient than the brute force method and avoids unnecessary comparisons. This is more of a greedy approach, as it always takes the largest possible Roman numeral value. Let's visualize this with an example, and then we'll see how to implement it in Python. Code implementation. Let's see the code in Python. We'll create a dictionary to map integer values to their Roman numeral counterparts. Then, we'll iterate through the dictionary in descending order, trying to use the largest values where possible to build the Roman numeral string. We'll use a while loop to continue this process until we've converted the entire input. This will maintain the most efficient approach. The code is clear, concise, and easy to understand. Now, let's walk through it, explaining each line and the logic behind it. We start by defining a dictionary with the mapping, and then use a while loop to greedily iterate and convert our input number to its Roman numeral equivalent. It's quite straightforward and remarkably efficient. Time and space complexity. The time complexity of our optimal solution is O of n, where n is the number of digits in the input integer. This is because we iterate through the input number once, and each iteration takes constant time. In terms of space complexity, we use a constant amount of extra space for our mapping dictionary and the result string, so space complexity is O of 1. Compare this to the brute force approach, which, as discussed before, has an exceptionally poor time complexity. This optimization makes a huge difference, especially when you're dealing with extremely large input numbers, often encountered in challenging coding interviews. The greedy approach proves to be highly effective. Engagement break. So, that's how we solve the integer to Roman problem efficiently. Before we wrap up, I'd love to hear your thoughts in the comments below. Did you find this explanation helpful? What other LeetCode problems are you struggling with? And don't forget to like this video and subscribe to the channel for more coding tutorials and algorithm walkthroughs. Hit that notification bell so you don't miss out on future uploads. Sharing this video with your friends who are also preparing for coding interviews would be awesome too. Let's keep learning and growing together. Conclusion. In this video, we've tackled the LeetCode integer to Roman problem, exploring both a brute force and an optimal solution. We